Hey everyone, and welcome to CS121 lecture number 7. In this lecture, we're going to be talking about maps. So previously, you've already been introduced to one way that we can organize and store our data using a data structure called the vector. And today, we're going to be talking about a new data structure called the map. So you've already seen how vectors are useful for storing a sequence of items, and they come in handy, especially when you want to store a list of elements like this list of names. But what if we wanted to associate data with each of those elements? For example, say for each of these names in this vector here, we want to also associate them with that person's favorite fruit. So one thing that we could do is create two vectors. So we could have one vector that stores everybody's names, and then another vector which stores their favorite fruits. And then we'll have the index kind of be associated with the index in the other vector. So say in the first vector, we have index 0, Alex, and we look at the second vector and we see at the same index, at index 0, we have pineapple. So we can tell that Alex's favorite fruit is pineapple. And the same thing for me. JC, I'm at index 3. So you can look at the second vector and you know that my favorite fruit is mango, which is also at index 3. So this would technically work, but if you can't already tell, this would get very tedious and it's very error prone because as we add more people, we have to modify a separate vector, and we have to kind of worry about keeping track of two different vectors and making sure that the indices of each vector's elements correspond correctly to each other. So instead of having to worry about two separate vectors, we can just use one data structure that's built exactly for this, called the map. So maps allow us to make associations between two different types of data, a key and a value. That means that they are data structures that contain key value pairs. And the reason that they're called maps is because they help us establish associations or mappings, such as mapping from a student's name to their grade, or mapping from the name of a class to the number of students that are enrolled in that class. Or if you have a big essay, you could map from a particular word in that essay to the number of times that that word pops up, or the frequency of that word. So having the ability to store associations between different types of data is extremely useful and widely used in the real world. And you'll find maps also very useful to solve some of the coding problems that you're going to encounter during interviews. So maps are also sometimes referred to, for example, in Python, as dictionaries. And I like to bring up this analogy because you can think of a physical dictionary of words. We have a word, and we use a dictionary to look up the definition that's associated with that word. And in computer science, maps accomplish the same thing because we have a key in mind, and we can find the value that is associated with that key. In other words, we can use a key to find the value that it maps to. So if you're like me and you're a visual learner, when you think of maps, you can visualize this dictionary, right? The key in a map is like the word that we're trying to get the definition for. And the value in a map is that definition that is associated with that word. So how do we construct maps? Remember how vectors are containers, and we need to specify the data type of what is stored in that container. And a map is a container too, just like vectors. But what's different is that it's not a container of just one type of element. It's a container of key value pairs. So that means that when we construct a map, we need to decide what the data types are for both the key and the value. So in this line of code, we are constructing a map whose keys are strings, like a person's name, and the values are also strings, the favorite fruit of that person. So in this line, we're creating a map called fav fruits, and we're going to have the key be the person's name, and it's going to map to the value, which is going to be that person's favorite fruit. So in that line that you just saw, we created a new map using the default constructor. And we know this because there are no parentheses following the variable name fave fruits. We're declaring a map that maps from strings to strings. And because we're not passing any parameters after the fave fruits variable, we know that this is calling the default constructor. So at this very moment, once we run this line of code, we only have an empty map. There's nothing in it. There are no elements. So how do we add key value pairings to this map so that we can associate people with their favorite fruits? So we can use a member function called insert, and we can access that member function using dot notation. So we can call insert by specifying the variable name followed by a dot, and then we're going to use the name of the member function insert, which takes in a key value pair. So in C++, the syntax for a key value pair will be this curly braces that you see with the key, and then followed by a comma, and then the value. So within that curly brace is one key value pair, which will comprise one single element within that map. So we can add the name Alex and associate it with the value pineapple. And I can do that with the next name and the next key value pair, and then add my key value pair and associate JC with my favorite fruit, mango. So how this would look like when we visualize it is that every row in this diagram here represents a key value pair, right? The key Alex maps to his favorite fruit, pineapple, and the key JC maps to my favorite fruit, mango. So every row here is a single element within the map, where each element in a map is a key value pair. So we can access elements in maps just like how we do in vectors with a member function called the at function. But the difference here is that instead of using the index like we do for vectors to access a particular element at a given index, for maps, we pass in the key. We want to find the value that's associated with that key, right? So if I want to find the favorite fruit of JC, the key is JC. So we can pass in that key to the at member function. We call the at member function, and we pass in the key JC to find that mango is what's associated with that key. So you can kind of think of the key as what unlocks the value. So the key value pair, the key kind of unlocks that value. And the last member function that we'll cover is size. So the size member function for vectors, if you remember, allows us to find the total number of elements in that vector. But for maps, a single element in a map is a key value pair. So when we're talking about what is the size of this fave fruits map, we'll get 4 because there are 4 key value pairs, right? So every element within the map is a pairing, right? Because we're having an association between a key and a value. So Alex mapping to pineapple, that is one pair, that is one element within the map. So in this map, there are 4 rows, there are 4 key value pairs, and that is what the size member function would return.